I have been alluding to plugging in my speaker. I've been talking about this that I have a checklist, a procedure for solved circuits, and I've said, yeah, I'll show another lesson. Here it is. Mixed. We're going to be looking at mixed resistor circuits. These are circuits that have some series parts and some parallel parts. To solve these, step one, I always label downhill. Okay, I almost call that step zero. That's just getting organized. Step two, I'm going to try and find the total current leaving the battery, because if I know that, the question's going to fall apart. Basically, I look around for amps. What's our abbrev for amp? A? What's the first letter of the alphabet? Basically, after I label downhill, the first thing I'm doing is I'm looking for A's. Okay, if you're looking for a dumb way to remember that. Then I look for any place in the circuit where I know two things. I've done that knock, knock. I know two things, then I know four things. And as soon as I find something else, I go back and I try step two. If I can't do that, I ski using Kirchhoff's laws, the law for current and the law for voltage. And again, every time I find something, I go back to step two. I ask, hey, now can I figure out the total current? As a last resort, I will rewrite a circuit in its simplest form. And we'll run into some that you have to do that for today. Example 1 says, identify resistors in series or in parallel. I'm just going to label this. I'm going to call this R1, R2, and R3. Which resistors are in parallel with each other? Yeah, parallel means they have identical voltage drops between them and nothing funky going on either. We would say R2 is parallel to R3. If I wanted to combine them, I would go 1 over R2 plus 1 over R3 equals, hit my reciprocal button. And I could combine these. I'm just going to give myself a bit more room. I'm going to put the R3 out here. Don't write this down. I could combine these as a single resistor. And then I would have this mathematically equivalent resistor in series with R1, and I could combine it. How would I combine it if it was in series? Or add them up. I'm going to call this R1, R2, R3, R4, R5. Which resistors are in series with each other? Which resistors are in series with each other? 3, 4, and 5 are in series with each other. What about R1 and R2? Are they in series with each other? No, look, there's a junction in between them. If there's a junction in between them, they're not in series with each other. But if I was analyzing this circuit, what I would do is I would turn it into this circuit. How would I do that? I could combine 3, 4, and 5 into one single Uber resistor. And then this circuit would look like this. I would have R1, I would have R2, and I would have I'll call it series for now. And doesn't that now look exactly like the first example? Now I could combine these two by using my parallel rule, 1 over R2 plus 1 over R series reciprocal, and then I would have turned it into two series resistors. I can add that together, and I can turn it into one resistor. Now, why do we want to turn it into one resistor? We're trying to find I total, and I know that I total is going to be V total over R total. If V equals I times R, then I equals V over R, then I total equals the total voltage battery divided by the total resistance, 1 Uber resistor. Looking at this one here, I'm going to call this R1, R2, R3, R4, and R5. Which resistors are in parallel with each other? Ella, which two resistors are in parallel with each other? Okay, and they're not in parallel with 4 and 5. You can't combine all four of them, but what you could do is you could combine R2 is parallel with R3 using the parallel rule. What else is in parallel with another resistor? Yeah, R4 is in parallel with R5. So what you could do is you could write this as a single resistor. You could write that as a single resistor. And now you would have R1, the single resistor, and the single resistor in series. Add them up, and now you've got one resistor, R total. Okay? This one is interesting. I'm going to change colors so you can tell the difference. I'll call this R1, R2, R3, and R4. How would I combine R2, R3, and R4? Well, first of all, I should say this. Which resistors are in parallel with each other? I'll give you a hint. It's a trick question. Which resistors are in parallel? What are you shaking your head, Joseph? None of them are. A common mistake, people want to go, oh, 1 over R2 plus 1 over R3 plus 1 over R4. No, 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 no. These two are in series. Now, what you could do is you could combine these into one resistor, and lo and behold, now it's exactly like example 1. A resistor on top, 2 in parallel. And that's what we're going to be practicing, rewriting circuits. You don't always have to rewrite a circuit, but as a last resort. So I like example 2. I think of this as a solid B level question. It says find all voltages, currents, and power usage. Honestly, I would probably say this. You can scribble that out, and I'm going to say find power in the 15 ohm resistor, because I know that to do that, you have to find everything else. Okay. What's step 1? Label downhill. Downhill, 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 downhill. Gibson, what's step 2? I want to find the total current leaving the battery. Do you see amps anywhere in this diagram? Okay, but I checked that. Step 3 would be look for 2 things. Do I know 2 things on the 4 ohm resistor? I know. Do I know 2 things there? Do I know 2 things there? I checked though. Okay. Step 5, I'm going to try skiing. Or step 4. I think we're step 4. I'm going to try skiing. Here's a ski run. I start with 20 volts. So how many volts do I need to lose? You know what? Those two will add to 20, but I don't know which one is which. This is also a ski run, and the 4 ohm and the 15 ohm will add to 20, but I don't know which one is which. So skiing isn't going to help me either. I'm going to have to rewrite this. How am I going to do that? First, I'm going to combine these two into one resistor. How are the 10 and the 15 wired? They are wired in, looking for that starts with letter P. Okay, so I'm going to find 1 over R parallel. That's going to be 1 over 15 plus 1 over 10, or 1 over 10 plus 1 over 15. All of you want to try this on your calculator. Remember to take the reciprocal of your final answer. I think this works out evenly. Is it 6, I think? Yeah. I'm going to do a brief resketch. So what you're saying here, Gibson, is here's my battery. What was the voltage on the battery? What was this top resistor here? But this is the same as a 6 ohm resistor. Why is that so nice? How can I combine that 6 and that 4? Well, now those are wired in what? Start with the letter S. And so I'm going to argue that the simplest form of this circuit is still a 20-volt battery and a single 10-ohm resistor, because if they're in series, I'm allowed to just add them up. Oh, Gibson, now I'm good to go because I know that V equals I times R. Gibson, get the I by itself. How would I move the R over? So I total is going to be V total divided by R total. What's the total voltage source in this circuit? What's the total? You've gone to the punchline, but let's walk through it. What's the total voltage source? 20. And what's the total resistance of this circuit? What's the total current? In units, amps. So here's what that means now. I'm going to label that everywhere I can. That's 2 amps. Ooh. That's 2 amps. That's 2 amps. Up here, 2 amps. Is there 2 amps in the 10 and 2 amps in the 15? No. No. Okay, first of all, single resistor, 2 amps is going through there. I know the 4. I know 2 things. How many volts am I losing going through there? You can probably do it in your head. You're saying I lose 20 going through here? That would leave me no voltage to run that. How do I figure voltage out? V equals what times what? What's I? What's R? How many volts do I lose in that top resistor? Good. How many volts did I start with, Gibson? How many did I lose here? Leaving how many volts? And leaving how many volts? Now, because they wanted the power in the 15 ohm resistor, I do have a version of power with voltage and resistance. It's V squared over R. Can everybody go 12 squared divided by 15? What do you get? Sorry? 9.6. Probably what I would have done really quickly is I would have said, you know what? I know the current in this branch because it's V over R. 12 divided by 10, that's 1.2 amps. Gibson, how many amps were coming in? How many went down this middle path? How many amps must be going over here? And I could go, it's also V times I. Power is 12 times 0.8, which is also 9.6. I got a few ways to get there, but the power here is 9.6 watts. That's a nice, a good B minus or B level question. You can see how I can give up part marks like candy. I would almost certainly give you 1 mark if I saw the 6 ohms that you'd done the parallel. I would probably give you 1 mark if I saw R total. I would give you 1 mark if I saw that you noticed that V total was 20. 1 mark for finding the current, that's 4 marks. 1 mark for finding the voltage, that's 5 marks. 1 mark for finding this voltage, that's 6 marks. And then 1 mark for finding power, whichever way you wanted to do it, whether you're using V times I or V squared over R or I squared, or they all work. Example 3. How can I turn example 3 into example 2? More specific. What can you tell me about these 3 here? How could I write that as one single resistor? Just add them up. And so instead of a 12 and a 2 and a 6, I could just put 1 there, and now it's going to look just like that. Okay, let's do this. So the first thing I'm going to do is I'm going to find our series. Equals 12 plus 6 plus 2, 20. Yes? Or not? Yeah? Okay, I'll do a quick resketch. Now, as you get good, Presley, if you can combine steps, I'm okay with that. In my notes for your studying, I'm kind of showing everything. So my next mental thought would be, okay, we got 30 volts. Presley, how many volts in that top, or how many ohms in that top resistor? 6 ohms. How many ohms in the middle resistor going down? And we said this is the same as a single 20 ohm resistor. Hey, now we're home free. Now I'm going to combine the 5 and the 20. That's going to be 1 over R parallel is going to be 1 over 5 plus 1 over 20. R parallel is going to... This might work out evenly too. It's going to be 4 over... Yeah. 4, I think. But don't quote me on that. That was a lot of common denominators in my head. Is it 4? Okay. So how big is this resistor right here? These two parallel, if I combine them, they're the same as a single resistor. How big? 4. I'll quickly resketch that. So I'm going to go 30 volts, 6 ohms, 4 ohms. What's the total resistance of this circuit, Presley? Yeah, in the previous question, a couple questions ago, I actually, after I had the 4 and the 6, I rewrote it as a 10. I think I'm going to see if I can skip that step, because what I rewrote it for was so I could go to this equation here. So I've got that. I'm going to say, okay, my whole goal is to find I total, which I know is V total over R total. What was the total voltage? 30. Presley, what did you tell me the total resistance was? How many amps are flowing through this circuit? This question's going to fall apart. And then I would label, let's see, that's 3 amps. That's 3 amps. Not only that, knock, knock, I know 2 things. That's 18 volts. That's 12 volts, which does add to 30. I might go scooching up to my original diagram. How many amps are going through this 6 ohm resistor, Ella? Caught you mid-yawn, sorry. How many volts? 18 volts. Okay. By the way, this question said find all voltages, currents, and power usage. Let's say find power in 2 ohm resistor, which, trust me, is going to require us to find pretty much everything else. Oh. How many volts, Ella, did I use in this branch down here, in this 4 ohm resistor? So from here to here, how many volts? Here to here, how many volts? So this must use 12 volts, and then these 3 will add to 12 volts. I don't know what they are, but in the 5 ohm, I know 2 things. How many amps is going through the 5 ohm? It's going to be 12 divided by 5. What'd you get? 2.4? How many amps are coming into this junction, Ella? How many went down? How many amps in the 12? How many amps in the 6? How many amps in the 2? And you know what? Since all they wanted was the power, I can quit. What's the version of power that has current and resistance from your formula sheet? There is one there. What's the one that has I's and R's? So find where power equals V times I. And then I think next to it, oh, so 0.6 squared times 2. Power equals 0.6 squared. You know what? It's our notes, right? So let's go I squared R. It's going to be 0.6 squared times, what was it, Mr. Dueck? 2. How many watts of power is that using? Small answer, I'm thinking. What'd you get? 0.72 watts. Yeah. That might be a wall clock. That wall clock uses under a watt of power. I don't know what it is, but it's definitely not a light bulb. Okay. Or if it is, it's a pretty dim bulb. My mom says I'm a dim bulb. She means something different. Spotting the strategy? Okay, I think one more. What happens to the total current in this circuit, as measured by the ammeter, when the switch S is closed? Okay. Oh, and it says increase or no change, increase, decrease. I think I'm just going to solve it. So I'm going to draw a little line right here. On the right, I'm going to say while the switch is open. On the left, I'm going to say while the switch is closed. What's the total voltage in this particular circuit while the switch is open, Tony? What's the total voltage in this circuit while the switch is open? What's the total voltage while it's closed? I'm going to say V total equals 100 and V total equals 100 volts. What's the total resistance while the switch is open? That's fairly easy because while the switch is open, the 10 isn't part of it at all. It's a 20 and a 5 in series. Sorry? Good. What's the total current while it's open? I can even do it in my head. So can you. Because it's V total over R total. What's 100 divided by 25? What? Yeah. Okay. Let's repeat. Now, when we close the switch, now we're going to have 1 over R parallel equals 1 over 5 plus 1 over 10. Those two parallel resistors are the same as one resistor. How big? Tony, what'd you get? I can't hear you. 3.3, is that right, folks? 3.3, probably repeating, I'm going to guess. Okay. So now the total resistance is going to be 20 plus this 3.3 repeating equivalent. I think it's going to be 23.3 ohms. What's your total current? Now you'll have to go 100 divided by 23.333. Sorry? Let's call it 4.3. What's the correct answer? When we close the switch, is there no change, or does the current increase, or does it decrease? Increase it is. And if you want a proof, I would just say there it is. This is kind of strange because we added a resistor, yes? In parallel, when we added a resistor, did our total get bigger? If you add a resistor in parallel, our total gets smaller. This bugs kids because you're adding a resistor. Shouldn't resistance go up? Well, it's in parallel. On some hillside, you open another hillside over there, you can get more skiers on the ski slope, more current. So what would happen if these were all light bulbs? When you close the switch, what would happen to the brightness of the 20 ohm bulb? You get brighter. Why? Because power is I squared R. R hasn't changed, but I just got bigger. This bulb would get dimmer, even though there's more current overall with 4.3 amps. I guarantee, because now it's splitting some current, it's getting less than the original 4 amps it was getting when the switch was open. It's going to get considerably less. So this bulb would get dimmer, the 5 would get dimmer, the 10 would light up in the first place, the 20 would get brighter. Kind of counterintuitive, but that's what would happen. Is that okay? What's your homework? 1 is good. 2 is good. 3 is good. 4 is good. You can put a little star next to number 5. 5 is drawn weird because where is the battery? In the middle. Live with it. Or if you need to, you can redraw that as a mathematical equivalent that doesn't have a battery in the middle, and you might find that easier. I'll let you try and figure it out. 6 is good. Ooh. What's 6 asking me to find, Carter? You know what? I'm starting right after I labeled downhill. I'm sure I'm starting right there because that's where I know 2 things. That's probably the crack in the armor. This one, I don't think you'll need to rewrite. This one you'll need to rewrite. Number 1, sorry, number 3, and number 2, and number 1. 7 is good. Also asking you to find the cell voltage. 7 is probably tougher than I would ask on the test. The key is they did tell you the current in the 6 ohm resistor. They said you got 3 amps going through there. That tells you an awful lot with a bit of cleverness. 8 is good. You can skip 9. You're going to be getting a lot of practice circuits to solve next class as well. Let me pause the video.